Section 6.5, Solving Square Roots and Other Radical Equations. By the end of today's lesson, students are going to be able to solve square roots and other radical equations. The first example we're going to look at is how we solve square root equations. And this should be very simple because you guys should be very used to square roots and how to get rid of them. So the first step you need to remember is you have to get the radical, whatever the radical is, in this case it's a square root, by itself before you can do anything. So, since after the square root of 4x plus 1 there's a minus 5, we have to get rid of that minus 5 before we can get rid of our square root. So to get rid of the minus, we're going to add 5. So that gives me the square root of 4x plus 1 equals 5. And then to undo a square root, we're going to square both sides. So that gives me 4x plus 1 equals 25. And now it's just a simple equation. So to move positive 1 to the other side, I'm going to subtract it. 4x equals 24. And then to get rid of the 4, we divide by 4. And x equals 6. Now you can check to make sure you have the right answer by plugging 6 in for x and make sure that it equals 0. So 4 times 6 is 24, plus 1 is 25. Then you take the square root of 25 and you get 5, and 5 minus 5 does give you 0. So when you plug 6 into your original equation, it does work, so this is your correct answer. Now we're going to look at solving other radical equations besides the square root. So we have 2 times the quantity x plus 3 to the 2/3 power equals 8. So you might be thinking, well, this problem doesn't have a radical in it. And it actually does. Remember, if you have an exponent that's a fraction, that's the same thing as a radical. So you can either leave it like this or you can convert it into a radical, whichever one you like to see best. But again, just like that first slide we did, you have to get the radical or the thing with the exponent all by itself. So to get rid of that 2 out in front, we divide by 2. Never can you distribute that 2 through that parentheses because it's to the 2/3 power. So that gives me x plus 3 to the 2/3 power equals 4. Okay, now if you want to, you could change it to the cube root of x plus 3 quantity squared, but you don't have to do that. Let me show you an even easier way. So to get rid of the 2/3, you're just going to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. Okay, whatever you do to the left-hand side, you also have to do to the right-hand side. Okay, again, 2 on the top, 2 on the bottom is going to make it cancel out. 3 on the top, 3 on the bottom is going to make it cancel out. So you just have x plus 3, and then you have 4 to the 3/2 power. So remember, that's the same thing as the square root of 4 to the 3rd power. So the square root of 4 is positive and negative 2. Don't forget that, otherwise you're going to be missing one of your answers. And then you have to raise that to the 3rd power. So positive 2 to the 3rd power is 8. Negative 2 to the 3rd power is negative 8. So I just wrote 2 equations so that I could go ahead and solve it. So to move my positive 3 to the other side, I'm going to subtract it. So x equals 5. To move positive 3 to the other side, again, I subtract it. And that is going to give me negative 11. And then again, you're going to want to plug those into the original equation to see if it checks, and both 5 and negative 11 do. Now we're going to look at an example when we have to check for extraneous solutions. And you know that you have to check for extraneous solutions in this example and not the other examples is because there's an x on the left side and there's an x on the right side. Examples 1 and 2 only had one x. So again, get everything away from your radical or everything away from the thing that has the exponent. So to move -5 to the other side, we add 5. So that gives me the square root of x plus 7 equals x plus 5. To undo the square root, you square both sides. Now you have to be very careful when you square the right-hand side. That means that you need to FOIL x plus 5 times x plus 5. So that gives me x squared plus 5x plus 5x plus 25. And we're going to go ahead and we're going to simplify that to x squared plus 10x plus 25, and then I'm going to bring down the equals x plus 7. All right, again, I have x's on both sides, so I need to bring them all to one side, and you always want to keep x squared positive. So I'm going to subtract x, and I'm going to subtract 7. That gives me x squared plus 9x plus 18. Since it's a quadratic equation, you are going to try to factor this. So what multiplies to 18? That adds to positive 9. So that's going to be x plus 6 and x plus 3. Set them equal to 0 using your zero product property, and you get x is -6 and x is -3. Okay, so now this is very important for you to check your answers. I am going to plug x into my original equation, and I'm going to start with my -6. So I have the square root of -6 plus 7 minus 5 should equal -6. So -6 plus 7 gives me 1. The square root of 1 is 1. And then I have 1 minus 5 equals -6. So if I do 1 minus 5, I'm going to get -4. And since -4 does not equal -6, x equals -6 is extraneous. Okay, let's check and make sure that -3 works, because it could be extraneous as well and we could have no solution. So I plug it in for x into my original equation. So -3 plus 7 minus 5 equals -3. -3 plus 7 gives me 4. The square root of 4 is 2. 2 minus 5. 2 minus 5 does give me -3. And so since that works, your only solution is x equals -3. The last example we are going to look at today is solving equations that have two radicals. So our first step had always been to get a radical by itself. That's going to be the same step. You have to get at least one of those radicals by itself. So this second radical, since it's minus the square root of x, it's easy just to add the square root of x to the other side. So you have the square root of 5x plus 4 equals 4 plus the square root of x. If you wrote it as the square root of x plus 4, that works as well. So since it's a square root, to undo it, you square both sides. Again, that means you have to FOIL 4 plus the square root of x times 4 plus the square root of x. A lot of you guys are going to make the mistake and you'll just distribute that little 2, and that's going to be the wrong answer. 4 times 4 is 16. 4 times the square root of x is 4 square root of x. Again, another 4 square root of x. And then the square root of x times the square root of x is just x. Okay, let's combine like terms. So that gives me 16 plus 8 square root of x plus x equals 5x plus 4. Now after you FOILed, you notice that you still have a square root of x. So I need to move the x to the other side and the 16, so that way I can undo that square root of x. So to move x, I'm going to subtract it. To move 16, I'm going to subtract it. So that gives me 4x minus 12 equals 8 square root of x. Now a lot of you guys are going to be you're going to attempt to divide by 8, but if you notice over here, 8's not going to go into 4 perfectly, and it's not going to go into 12 perfectly, and you're going to get some fractions and you might not know what to do. So instead, you're just going to square both sides. Again, that means we have to FOIL 4x minus 12 times 4x minus 12. So 4x times 4x gives me 16x squared. 4x times 12 gives me minus 48x. Again, another minus 48x. And negative 12 times negative 12 is going to give me a positive 144. Equals 8 times 8 is going to give you 64 on the right-hand side. The square root of x times the square root of x is just going to leave you with x. All right, let's keep going. I'm going to move up here to the top and try to squeeze this in. So I'm left with 16x squared. Negative 48x plus negative 48x gives me negative 96x. And then you have plus 144 equals 64x. Okay, bring it all to one side. And again, you want to keep the a positive. So I have 16x squared. Negative 96 minus 64 is going to give me negative 160x. And then plus 144 equals 0. Before you try to factor that, since all of those numbers are pretty big, I would see if they had a greatest common factor between 16, 160, and 144. And in all of those, 16 goes into them, so that leaves you with x squared minus 10x plus 9 equals 0, and that just became a nice problem to factor. So numbers that multiply to 9 that add to negative 10 are going to be minus 9 and minus 1. Okay, use your zero product property and set them equal to 0. So that gives you x equals positive 9 and x equals positive 1. Now we need to check to make sure they both work. All right, we're going to start by plugging 9 into our original equation. So we have 5 times 9 plus 4 minus the square root of 9 should equal 4. So 5 times 9 gives me 45, plus 4 gives me 49, so that gives me 7. Square root of 9 is 3, and yes, that is going to give me 4. So now let's check the other one. Let's plug in 1. We have 5 times 1 plus 4 minus the square root of 1 should equal 4. 5 times 1 is 5, plus 4 is going to give me 9. The square root of 9 is 3. The square root of 1 is 1. 3 minus 1 does not give me 4. So 1 is extraneous. Your final answer in this problem is only x equals 9. I know this problem takes a lot of work and it takes foiling normally at least twice. Please make sure that you write down as much work as possible so that you don't make a mistake because you're trying to do shortcuts or whatnot.